Bottom of page 584, looking at lesson 9.6, which we talked about quadratic formula. This just kind of summarizes different methods for solving quadratic equations, what method and when to use it. So one method that you might use is graphing. It says if you have a graphing calculator handy, also if you're allowed to use a graphing calculator, right? Square roots, it says use if the equation has no x term. So like, for example, if we had x squared equals 12 or something like that, we could just take the square root plus or minus on both sides. Factoring, if you can factor the equation easily. So if it's a trinomial, you know, a squared term, an x term, and a constant, we could try to factor that into two binomials. Completing the square, we can use if the coefficient of x squared is 1, but you can't easily factor the equation. So the idea there is that if there's a number in front of the x squared and you have to divide everything, like if it's 17x squared and you have to divide everything by 17, that's not going to come out nice at all. You're going to have all kinds of fractions and stuff. That's probably not going to be the easiest way. If there's not a number in front of x squared where you don't have to divide, you do have that option, completing the square. And then quadratic formula says we can use that if the equation cannot be factored easily or at all. Okay. And one thing about it is completing the square can work with anything. Quadratic formula can work with anything. Okay, so like even if you forgot about this, oh, it has no x term, even if you forgot, you could set it equal to 0. You can use quadratic formula with any equation that you're given. Okay, so that's an option. And like I said, it's kind of your choice in a sense with completing the square or quadratic formula, whichever one you find easier. I would just use that one. If you want to use a little bit of both of them just to keep practice up on both options, that's fine. So problem 3 asks which method or methods would you choose to solve each equation and explain your reasoning. So if you look at this on A, there's no x term, so easiest there would be doing square roots. In other words, we could add 9 on both sides, divide by 3, square root plus or minus, and we'd get our answer. Part B, it's already set equal to 0. We could try to factor it, and it would factor. It would be x plus 5, quantity x plus 5 times the quantity x minus 6 is how that would factor out. C doesn't look real great. We could try to factor it. The book says it can't be factored, so we'll take their word for that. Quadratic formula would be probably best because of the 6 in front of the x squared. Otherwise, you're dividing everything by 6 in order to do completing the square, and you're going to have fractions everywhere. D, we could use quadratic formula again, or completing the square, or if you're allowed to, you can use you can graph this on a calculator. It doesn't factor out nicely. The answers aren't going to come out real great, and so it just kind of depends on if you can use your calculator. If not, then you can go to either quadratic formula or completing the square, whichever you'd rather. And then E, kind of the same idea. That doesn't work out real great, so either quadratic formula or graphing it on the calculator. Probably not completing the square because we'd have to divide everything by -16, and that's not going to be real pretty. So if you look at the guide at 3, they're asking which method or methods would you choose to solve the equation and justify your reasoning. And part of this whole discussion is that, you know, when you guys get to like a final or something that's going over all this material, they're not going to have a section that says, this is the quadratic formula section, this is the factoring section. You're just going to have a bunch of problems, and they're going to say, solve these. And you're just going to have to decide what's the best method for me to solve that. So on part A, I would at least consider trying to factor this if we can do it quickly and see what happens. It is set equal to 0. There's no number in front of x squared, so it's not going to be too bad here potentially if it is going to factor. We can do x's, we can do subtraction on both sets of parentheses. And then if we do 6 and 2 or 2 and 6, that'll give us our minus 8x middle term that we need. So that actually does factor. So probably factoring would be the way to go for that one. Okay, and some of these, you know, if you're not sure, you could try to do a factoring on it, and then if you can't quickly come up with something, you can always fall back on quadratic. Like I said, quadratic is always an option, but if we're able to do factoring, the factoring is probably quicker if it actually does factor. So the next one here, there is no x term, so square roots would be the way to go. What we would do, just divide by 169 on both sides and then take the square root plus or minus. And both of those are perfect squares, so it actually would come out pretty nice. And part C, this one we would want to use the quadratic formula. If we look at it, we've got a 5 in front of the x squared term. So if you're doing completing the square, you'd have to divide everything by 5. Or, you know, could be graphing. I'm going to say graphing calculator, because graphing it by hand, then the answers wouldn't come out very nice. We wouldn't be able to figure them out just from our graph by hand. The next part in the book talks about the discriminant, and we've already worked with the discriminant, we just didn't know what it was. So discriminant is the expression under the radical sign in the quadratic formula. So the discriminant, in other words, is b squared minus 4ac. B squared minus 4ac is our discriminant. It's the part under the square root. And when we use quadratic formula, the discriminant might be positive, it might be 0, or it might be negative. And the discriminant actually determines how many solutions we have, or zeros we have, or roots, or whatever we're going to call them, x-intercepts, okay? So if you look at just that part, if you just work out the b squared minus 4ac, if it's positive, then you're going to have plus or minus square root of some number that you'll be able to take the square root of, and you'll have 2 solutions. You'll have 2 real solutions. If it's equal to 0, plus or minus square root of 0, that's the same either way. So that actually is only going to be 1 real solution. And if the number under the square root is negative, we can't take a square root of a negative number, and so that has no real solutions. So you can see that on the graph also. Here, there's 2 solutions, there's 1 solution, and then this last one doesn't intersect the x-axis, has no solutions. Okay, so we're going to kind of just make a table here to look at the different cases then. So just to kind of organize our information a little bit here, we can make this table. If the discriminant is positive, it has 2 real solutions. An example of that, we could have 5 plus or minus square root of 10 all over 7. If the discriminant is 0, we have 1 real solution. Example, 3 plus or minus square root of 0 all over 2. again, square root of 0 is 0, so that's basically falls out. And we just have one answer. And if the discriminant is negative, we have 0 real solutions. An example of that, 2 plus or minus the square root of negative 7 all over 4. If we have a negative square root, we're not going to have any real solutions. So problem 4, it asks how many real number solutions does this equation have? The first thing we need to make sure that we do is get the equation set equal to 0. So this one, they didn't really show this, but they added 5 on both sides. That got them to here. At that point, if we're just looking at how many solutions this has, not what the solutions are, we can look at the discriminant. So we could label what A, B, and C are here, and then we're just looking at the discriminant. So under the square root is the b squared minus 4ac. So b is negative 3, we square that, minus 4 times a, which is 2, times c, which is 5. And then they worked all that out, they got negative 31. What that means is if we would use quadratic formula, we would have a negative number under the square root, which means we have no real solutions. So same idea, if you look at the got at 4a, they're asking how many real number solutions this equation has. I'm just going to rewrite it down here. So first thing, we need to subtract 7 on both sides. If you don't subtract 7, you're not going to have the right numbers, and you're going to potentially get the wrong answer for this. Again, we're just looking at how many real number solutions it has. So we're just looking at the discriminant. So b squared minus 4ac is what we're looking at here. So our a value here is 6, b value is negative 5, and c value is negative 7. You can either do like I did there, you can rewrite it off to the side so it's a little bit easier to see. And then we're going to substitute in. Now b squared, b is negative 5, so we're going to do negative 5 squared minus 4 times 6 times negative 7. Now what we have to remember, that negative 5 squared, we really don't need a calculator for this. We know it's negative 5 times negative 5, which would be a positive 25. Okay, you could type it in your calculator, then you got to make sure you put the negative 5 in parentheses. I think we can just handle it without even typing that in. But I mean, technically we could type all this in, our calculator can handle it, and we would get the answer. Now this other part, if you'll notice, it's kind of like we've got 2 negatives being multiplied back there, so that's going to end up being positive. So that would be 168. We add them together, I can already see what's going to happen. So I'm not really worried about exactly what this number is, but it would be 193. So since this is positive, that means under our square root we would have a positive number, which means we have 2 real number solutions. So if we look at the lesson check number 3, we've got a similar type problem here. They're asking how many real number solutions this equation has. So this one's already set, excuse me, this one's already set equal to 0. So we're just going to look at our values here. A is negative 2, B is 8, and C is negative 5. And again, we're just looking at that discriminant, the part under the square root. So b squared minus 4ac. So we'll substitute in. So 8 squared minus 4 times negative 2 times negative 5. So 8 squared would be 64. And then if you watch your signs on this back part here, we can multiply all these together on your calculator if you want, but really we probably don't even need it on this one. Negative times negative is a positive, positive times a negative is a negative. So this is going to be a minus something. So since the numbers are smaller here, we could just go with 4 times 2 is 8, and 8 times 5 is 40. So we've got 64 minus 40, which would be 24. So that means once again we have 2 real solutions. So this gives you an idea of how to work with quadratic formula and the discriminant.